The last definition in this section describes what it means to say the word independent events. So we say that two different events are independent in the sample space if the probability of A and B is equal to the probability of A times the probability of B. So normally those, that means that the first event does not affect whether the second event is going to happen or not. So that's what we mean by independent events. So like for example, in a coin toss, if you land heads the first time, then it doesn't mean that you're going to land heads the second time. It also doesn't mean that you're going to necessarily land tails the second time. It could, anything could happen. So let's take a look at example number 5 where we have a coin that is loaded. So this is not a fair coin. One side is a little bit heavier than the other side. So that means that the probability of heads is going to be 0.6. So the probability of landing H is in this case 0.6. So the probability of landing tails, or in other terms, not heads, is going to be 0.4. So again, just like we said, just because the probability of heads is a little bit higher doesn't mean that every time you throw the coin, it's going to land heads. It could be either or. So that's an example of a situation where the events are independent, basically. Okay, so now the question is, what's the probability of obtaining 2 heads? So you toss the coin twice. What's the probability of landing 2 heads? So the probability of landing heads on the first try and heads on the second try. Well, the probability of landing heads the first time is 0.6, right? So that's basically the probability of landing heads the first time, multiplied by the probability of landing heads the second time. So 0.6 for the first time, and since the events are independent, we multiply by 0.6. So the solution there is going to be 0.36. That's it. So to make it less confusing, I'm going to write H1 for landing heads on the first toss and H2 for landing heads on the second toss. So 2 means the second toss and 1 means the first toss. So H1, H2, that way it's a little bit clearer. So now the question is, what's the probability of obtaining 1 head? So the probability of obtaining at least 1 head. So, well, if you think about it, how can we get 1 head? We can get 1 head by either tossing heads on the first try and tails on the second try, or vice versa, tails on the first try and heads on the second try. So that means that the probability of getting at least 1 head, or rather, the probability of getting 1 head, not at least 1 head, just 1 H, in this case, is going to be the probability of landing heads on the first try and tails on the second try, plus the probability of landing tails on the first try and heads on the second try. And since these events are independent, that means that P of H1 is going to get multiplied by P of T2, and T2 means that the probability of landing tails on the second toss, plus P of T1, landing tails on the first toss, multiplied by P of H2. So P of H1, the probability of getting heads is 0.6 always, and 0.4 for the tails. And again, 0.4 for the tails, multiplied by 0.6 for the heads. So calculator time. This turns out to be 0.48, or roughly speaking, 48%. Now for part 3, it says, what's the probability of obtaining no heads? So probability of no heads. Well, that means that I got tails on both of my tosses. So in other terms, this is the probability of getting tails on the first toss and tails on the second toss. But, again, these events are independent, so that means that I should just multiply the probability of T1 by the probability of T2. And the probability of getting tails is 0.4, and the probability again is 0.4. So calculator time, this means 0.16. So now, what's the probability of obtaining at least 1 H? So the probability of at least 1 H. So this means that we could have 1 head or 2 heads. So this is the probability of getting 1 H plus the probability of getting 2 H's. Now the probability of getting 1 head, I believe we calculated that somewhere. It was 0.48. And what's the probability of getting 2 heads? I think we did that as well. That was the First option, 0.36. And calculator again. So 0.84. Okay, another way to calculate this is to use the difference rule and say that it's 1 minus the probability of getting 2 tails. And that would work as well. If you want to do it that way, that's fine. But again, this illustrates the concept of having independent events. The final definition here talks about mutually independent events, and so this basically is the same concept as independent events, but in this case we're allowed to have multiple events, not just 2 of them. So an example of that might be something like this one down here, where it says a coin that is loaded again, so it's an unfair coin. It lands heads with a probability of 0.6. So the probability of H is 0.6. That means the probability of getting tails is 0.4. Suppose that the coin is tossed this time 10 times. And the question is, what's the probability of obtaining 8 heads? So now, to get 8 heads, I can get 8 in a row and then 2 tails. Or I can get 1 heads and then 2 tails and then so on and so forth, you know, heads. It could happen in multiple different ways. So the probability of obtaining 8 heads is going to be a little bit tricky here. We're tossing the coin 10 times. So that means, first of all, we got to figure out how many ways we can rearrange the heads, the 8 heads out of 10 tosses. So that determines the number of ways we can get 8 heads out of 10 tosses. But each head can be obtained with a probability of 0.6. And remember, there's 8 of them. And then we got to multiply by the probability of getting tails for the remaining 2 tries. So 0.4 to the power of 2. So this will give us the probability of getting 8 heads when we tossed 10 times. So this is the answer so far, and let me finally put it in the calculator and get the total. I apologize, I had the wrong number written down. It's supposed to be 45, and then when you put it all into calculator, you get 0.1209. So roughly speaking, let's say 12.09%. And finally, what's the probability of getting at least 8 heads? The probability here is going to be the probability of getting basically 8 heads plus the probability of getting 9 heads plus the probability of getting 10 heads. And so to calculate, we're going to use the same kind of logic we did in part 1. So first of all, how many ways can you get 8 heads out of 10 tosses? Multiply by the probability of getting heads, and multiply that by the probability of getting tails. Now we need 10 tosses, and 9 of them should be heads, and that happens with the probability of 0.6 to the power of 9 times 0.4 to the power of 1, because 1 toss is tails. And finally, the last remaining one, 10 to choose 10, and then 0.6 to the power of 10 times 0.4 to the power of 0. So this leads to the following answer. The total there is 16.73%. This leads to basically what we call binomial probabilities, which is a higher level concept. And you know, if you're going to continue taking more math classes, you're probably going to end up using that concept. But I used pretty much this formula down here to figure out the probabilities. And you know, you're advised to use the same formula again to get the solutions.